The next time you are out of soccer balls, use Buckminster fullerene. It resembles a soccer ball after all. But what is Buckminster fullerene? Come, let us find out. The phenomena of pure element existing in different forms is called allotropy. For example, the element sulfur exists as three allotropes: rhombic, monoclinic, and plastic sulfur. Oxygen exists as diatomic O2 and triatomic O3 gases. The phenomena of allotropy is particularly significant in the case of carbon. Carbon exists as diamond, graphite, and the relatively new fullerenes in the crystalline form. Let's study the three allotropes of carbon in detail. In a diamond, the electronic configuration of carbon is 2,4, that is, it contains 4 electrons in its outermost orbit. It shares all the 4 electrons with 4 other carbon atoms. So, there are no free electrons left in the carbon atoms. This rigid structure causes a diamond to exist as a very hard substance which does not conduct electricity. On the other hand, if graphite is connected to the circuit, the bulb glows, indicating that graphite is a good conductor of electricity. Let us find out what makes graphite a good conductor. In graphite, there are 4 valence electrons of carbon. Out of these 4, it shares 3 electrons with 3 other carbon atoms, while 1 electron remains free. This forms a hexagonal structure. Many such hexagonal structures are arranged one above the other. Thus, in graphite, each carbon atom gives 1 free electron which remains delocalized between these hexagonal structures. So, there are a large number of delocalized electrons free to move between these hexagonal structures. Fullerenes is another allotrope of carbon. In the structure of Buckminster's fullerene, each carbon atom is covalently bonded with 3 other carbon atoms and forms a spherical, hollow molecule containing 60 carbon atoms. These molecules resemble tiny soccer balls. As you must have noticed, soccer balls are designed in a hexagonal or pentagonal form. So, we can conclude that though all the allotropes of carbon are composed of carbon only, they differ from each other in their physical state of existence due to different bonding between the atoms. Another element which exhibits allotropy is phosphorus. It exists in white, red, and black forms. White phosphorus has a tetrahedral structure. Red phosphorus has a long polymeric structure containing several P4 molecules. The black phosphorus has an orthorhombic structure. To summarize, the phenomenon of a pure element existing in different forms is called allotropy. All allotropes of an element are composed of the same atoms but differ from each other in their physical state of existence due to different bonding between the atoms. Carbon exists as diamond, graphite, and the relatively new fullerenes in the crystalline form. Fraternal twins come from the same mother, but they can look and behave differently due to the variations in their genes. Diamond and graphite are quite similar to what I just mentioned. Confused? Watch the upcoming videos to clear your doubt.